Welcome to this project on deep learning with Keras and Tensorflow2. This is a deep learning project. As we know, deep learning is based on neural networks, and sometimes the two phrases are used interchangeably. However, a neural network can be quite simple in structure, whereas deep learning is about a large and sophisticated neural network. So a neural network at its basic form has an input layer, hidden layers, maybe one, maybe two, and an output layer which can lead to classification or regression. So this project is about classification. I'm not going to go into the mathematics of this in detail, although they are fantastic, because that's a whole other presentation. So here's some basic neural networks which I built myself. LE is life expectancy, so this is one hidden layer. These scalars are the weight, so it's very clear to see which of the features impacted the output layer the most. The minute you start building in more layers, the more complex it gets. So this has got two hidden layers. However, it has to be said that the more hidden layers you have, the more sophistication the model can have and the more power. So one of the main algorithms which neural networks is based on is gradient descent, which is a way of approaching a mathematical goal iteratively. So basically the model learns. There are different types of gradient descent. As you can see, the stochastic gradient descent is not very quick. However, the batch gradient descent is extremely rapid, smooth and effective. So there were two parts of this project. The first one is to look at the iris dataset. This is a very famous dataset which looks at sepal width, sepal length, petal width, and petal length of a group of irises and tries to classify them in one of three types. So you can see here that this type, which happens to be setosa, is clearly demarcated and a very clear decision boundary here. Whereas the other two types, there's a little bit of fuzziness on this decision boundary. So what I was trying to do was to use neural networks and deep learning to create quite a sophisticated model, first of all on the iris dataset and then on a real world dataset. So I imported the libraries, I downloaded the data, imported the perceptrons, built an image classifier, this is the model but it'll come up later. So this is the deep learning on the iris dataset. Again, really clear demarcation between setosa and non-setosa classification, this time on petal width and petal length. So then I applied this learning to show the different types of activation functions within a neural network or deep learning situation. These allow for a very, very sophisticated model to be built with a lot of appreciation of the non-linearity of the data. So you can see the different activation functions, step, sigmoid, tan and relu. There are others, but these are the main ones, and these are their derivatives, so you can see how they operate. So the real world data is called the MNIST NIST dataset. It's about clothing, among other things, but I was looking at the fashion classification. So here we have some of the items in the dataset. Here's the type of model, and here's the model learning from the process, and here's the evaluation of the model. And you can see that loss depreciates each time, whereas accuracy increases and stabilizes. Thank you for your time.